Hello and welcome back to our video. Today's video will be about Introduction to Breadboard. So we'll learn about Breadboard on TinkerCAD. So first, remember, check that you are in the Circuits section and then click Create New Circuits. And then remember that you have to enter exercise. It's 1.5 now. Undo the project name. Now, in TinkerCAD, what you need to do now is, again, scroll down and look for Arduino Uno. The next thing that we need in this section is the breadboard on the top right corner of the Arduino Uno. So bring one breadboard into the scene. So this thing called breadboard is basically a device that we can use to check our circuits. In TinkerCAD, I know that we can straight away build something quick, easy, and then test run it directly. But in real life, we can't keep connecting things in small pieces or using soldering all the time. So in real life, we need something like this called a breadboard in order to test run our circuits before we put it fully in use. So with this breadboard in, I want you to do a few things. First is to understand what is breadboard. So we'll look at its connection first. So this is how our breadboard look like. Over here, I will talk about how the breadboard connect things. Basically, inside this hole, there are a few things. One is that on the wall of this hole, there will be some metal on the side so that whenever you plug something in, it will be connected. And inside, there's another thing. Basically, on below the hole, there's actually a metal plate attached to it as well. And the metal plate actually can help you to connect each electronics together. But first, we need to learn the layout of the breadboard. So if you look on top over here, okay, there's a plus and a minus sign. Basically, these two can be used as your plus for source and negative for your ground. When we have a source which is called common source connected over here, that means all electronic part can be connected to anything in this row to get the power. So basically, it is this one over here. Okay, anything on this line can be connected to get power source if you plug a source in, which means this whole row is actually connected. And then another one is over here, the negative. Okay, basically over here, this whole row is also connected. Okay, so that if you connect G and D to any of the hole, then you can actually use it as something called a common ground. Okay, if you are not sure about what is common source and common ground, we'll look into it later when we go back to TinkerCAD. But remember, you just need to remember, the first thing is this whole row is connected, and then this whole row is also connected. It is the same with the two row at the bottom. Okay, this whole row is connected, and then this whole row is also connected. Okay. Now, on the breadboard itself, the main working area, if you look over here, there's A, B, C, D, E, F, G, H, I, J, and then there's number as well. Okay. Basically, on each number, for example, number 1 over here, the A, B, C, D, E are all connected. Okay. Basically, this line are all connected. And then F, G, H, I, J is again, the whole line is connected, but remember that E cannot jump over to F. With a split in the middle, it basically means that these 5 are connected, but these 5 connected, but the two set is separated. Okay, it's the same for all other number as well. So if you draw everything, then we'll have a full layout of the breadboard. This is the full diagram of the breadboard. after you have drawn all parts that have connected. So basically, the top one, the whole line is connected, and on the main part, only 5 of them are connected. So you may be confused, what does it mean connected? It basically means that on this same row, the 5 of them are connected together, which means everything you plug onto one of the hole, it will be connected to the rest. Let me remove the diagram and show you an example. So basically, let's say we have this resistor. Okay, if I plug the resistor over here, okay, basically I connect it to 3F. Okay, basically what I did is that after I've connected it to 3F, the resistor, the end of resistor is now connected to this whole line, which means if I now put in another resistor and connect it over here, we can say that basically what happened is the electricity can now flow from this side going down, cross, and then go to another resistor. Okay, not sure if you can see clearly, but let me make the line thicker. So basically, if you have electricity connect to other side of this bottom resistor, it can now cross, okay, and then pass through this breadboard part that I say they're connected and reach the other end and flow through. Okay, that's how you connect the two resistors together. So this is the use of breadboard. So let's go back to TinkerCAD and then start to work on the breadboard. Now back to the TinkerCAD side. So basically, if I rearrange them first, I wanted to have my Arduino on top and the breadboard at the bottom. We'll talk about these two lines first. What we can do now is, like I say, 5 volts is the power source. So I can connect the source to the positive bit over here. So for easy to see, I will change it to red color. Okay, so basically what I did is, once I connect 5 volts to this line called the common source, okay, anything connected from this source will be able to provide power. If you look, when I highlight any of the hole on this line, it will show me this green section, which means the whole line is connected. Okay, it will be the same with this ground. So now, since this line is the common ground, so let's connect G and D to this line. Okay, which means this line is now our common source, this line is our common ground. What does it mean to be a common ground and common source? Let's build a basic circuit first. Put in a resistor, remember to change it to ohm, change the value to 200. Okay, rotate it first for easy connection. Remember that, like I said, these 5 will be all connected, which means if you put it like this, okay, it will connect to 26J and 26F. But since the line is also connected itself, it will make the resistor redundant, which means the resistor will not work if you connect it like this. Now back to this resistor, one way we can connect is horizontal like this. It is now connected to 10F and 14F. Okay, which means anything on this line and anything on this line, anything on this line is connected to this side of the resistor, and anything on this line is connected to left side of this resistor. Now give it some power, we can draw positive to 14, which means right now the 5 volts will provide power to this whole line, and since this one is connected to 14, which means now the 5 volt will provide power to line 14, which will flow through the resistor. But since this is incomplete, it won't work yet. The next thing we need to test it with is a LED. Okay, you can change the LED to any color again. Now put the LED, remember the squiggle line, the long one, supposed to connect to the source. Since we have source coming in and go into the resistor, which means the other side of resistor have to connect to the positive side. So we can just plug in like this. Okay, then lastly, the other leg of the LED that have connected to row number line have to go back to the ground. So instead of drawing from LED directly, we draw from number 9 and then put it back to the negative side. Then this circuit is actually complete. So the 5 volts will go into the positive. Okay, check for the only place that it can go, which is this wire coming here. For this whole row, it is connected, so it can go to any place on this line. In this case, it will go to this resistor, cross it, okay, then go into positive leg, which is anode of the LED, then leave from cathode, okay, then on this same line, you have this wire, through the wire, go back to this line. Okay, once it's reached this line, you have GND over here, so it will go back and we can start simulate. So you can see that the LED will light up. Okay, why we need a common ground is if we need the not just common ground but also common source. If we have a lot of components that need to connect to the source and the ground at the same time, then you can use it, because what we have done is once you connect 5 volts to this line, this whole line give you 5 volts, and once you connect GND to this line, this whole line are your GND. Okay, basically we just duplicate 5V and GND infinitely in this whole section. If you now click on this resistor, then copy it, Ctrl C, Ctrl V, or of course you can draw another one from here. Remember, change it to 200 ohm, 200 ohm. Okay, we put it on one place. Okay, now if I draw another one, let's see if I put it here. Okay, another one to your positive. If I change it to other color. Now I put another LED. Remember that since this one is positive, it will come down here. Okay, go through here. So this is the positive. So the LED positive side should be connected here. Remember, you can again change the LED color. And then now connected this line back to GND. Both of them should light up at the same time. Okay, so that even if you only have one slot of 5 volts, when you actually make this your common source, it can connect it anywhere. Okay, so it can provide a lot of 5 volts to a lot of different devices. And another thing is the ground. Okay, so since you have limited slot of GND ground, so you can connect it to this place, make it common ground, so that you can have a lot of ground over here. Now, the next bit is about the breadboard connection. So like I said, these 5 are connected, these 5 are connected. So the top bit is actually not connected to the bottom bit. Let's prove that. So since we already connect positive source over here, pass through a resistor, if the top bit and the bottom bit are joined, if I put resistor over here, it should, LED over here, it should light up. But when you press, it won't, because the top bit and the bottom bit is not connected. If you really need to connect the top and the bottom bit, you can move a bit. Okay, draw the line here and draw the line here. Then this line is connected, this line is connected. Then we can start simulate and see that this one will light up as well. Okay, that's the basic usage of breadboard. Today conclusion. Breadboard can be used to test circuits that haven't been built fully, which means we can use it to test the electrical circuits that are not final. The layout of breadboard is as follows, so that we can see that which parts are connected together. We use the positive line as a common source to provide power source for multiple components that use the same amount of voltage. For example, 5 volts usually if you are doing Arduino. And then we use the negative line on the breadboard to set as common ground, so that components that need to connect to ground can be connected directly to that line. That's all for today. Thank you and see you next time.